Hello, I'm Michael Steffes. I'm the Senior Applications Manager for High-Speed Amplifiers at Intersil Corporation, and I'm here today at ISSCC 2011 to talk about a part that was presented here by Gwilym Luff in paper 13.8, discussing a 3.3 volt 115 milliwatt differential ADC driver that on 0.18 micron CMOS. Our goal with this part was to deliver extremely low distortions to ADCs without consuming a lot of power. The emerging ADCs in the market today are really pushing the powers down. If we can't bring the driver power down with it, we've kind of lost the game. And so the converter we paired it with here for demonstration purposes is actually a 500 megasample 12-bit device that we're going to run on 250 megasamples here with our portable demo box. At that clock rate, we're only consuming 380 milliwatts, and with the amplifier at 115 milliwatts, I think we have almost a sub 500 milliwatt solution here. Now, one of the problems we're trying to solve here is how to get a single-ended signal, give it a bunch of gain, and get it to the ADC through a low-pass filter where we can control the noise power bandwidth and do that in a way that doesn't hurt the converter performance. Now, it turns out the converter performance is extremely easy to hurt. Distortions add up linearly, so if we want to hold less than a 1 dB degradation from the converter specs, we need to come in almost 20 dB better. So this particular converter is extraordinarily challenging to drive with that kind of a goal. It's about 88 dBc SFDR, and so if we want a 1 dB drop or a 2 dB drop from that, we have to be coming in with signals that are minus 105 dBc. We've achieved that with this, and we're demonstrating it. Here we're doing a 10 megahertz input with a 250 megahertz clock, and we can look at the FFTs, and we're seeing that we're getting about an HD2 of 93 and minus 85. That's darn close to the converter itself, but frankly 10 megahertz is really slow for this part. We did take lab data at higher frequencies with sources that are much more difficult to move around. And here we have some tests at 115 megahertz, full scale, two-tone, and right in here we see a couple of tones that are 85 dBc down. We can't filter these IM3 tones, so it's very important to have native linearity, which was certainly achieved in this part. This part's been in development for a while. Gwilym presented it this week, and we're offering it for sale starting next week. So the part is introducing. Hopefully it'll do some good for the converter interfaces. Thank you.